I haven't made a video for a while, and frankly, I haven't seen a need to make one until now. I've been watching a lot of YouTube videos about solar generators to see if anyone has made a hand carryable system as good or better than what I have made. I haven't found one. But one thing I've noticed while watching these videos is the people testing their solar generators, they basically only quote manufacturing specs, only plugging things into them to see if they work. They're not really testing them to see if they can meet the manufacturer specifications or see if they're worth the money they cost. Except in a few cases, they did some testing. But what I would like to do in this video is to test a couple of popular solar generators to see if they can actually meet the specifications that are claimed and to see if they're worth the value for what you're getting. Also, I will include my ultimate solar generator for a comparison to what is possible in a DIY system. This video will get technical, so if you don't care about details, this video is not for you. But for those that really want to understand the details and abilities of solar generators, let's get started. As you can see, we are going to be testing the Energy Kodiak Gold Zero Yedi 1000 and my DIY system for comparison. Some people have compared the Kodiak with the Yedi 1400, but the Yedi 1000 is a closer match. The Yedi 1400 has a much larger battery than the Kodiak. I do not own a Kodiak, so I will be using information about it I have compiled from YouTube. I will be using many people's videos that actually tested the Kodiak. In most of the information, 2 or more people had similar test results, or I won't use it. If you want to, you can watch the dozens of YouTube videos I watched and see the same results. I'll be testing a Yedi 1000 that I bought. I will explain why I bought it when I already have a better system in a few minutes. I decided not to film most of the testing I did, like many YouTubers do. It can be boring and take up a lot of time. I'll just explain what I did to get the results. The most expensive and important part of a lithium-powered solar generator is the battery. If your battery doesn't have enough stored energy to power your loads through the night and or can't charge up fully in cloudy, rainy, or snowy days in a grid-down situation, it's not going to be very useful. Also, if you'll be using it every day like I do, you will want it to have thousands of cycles, so you don't have to replace the battery every few years. The Kodiak has a lithium NMC type of battery, claiming to have 1100 watt hours on a 90 amp hour and 12.6 volts. In testing, the battery could only get about 830. It still had slight amount of energy left in it, so we'll round it up to an 850 watt hour battery, much less than what Kodiak claims. On one of the tests, the guy tested a 5000 BTU air conditioner and got 830 watt hours out of the system. Another guy tested it also on a 5000 BTU air conditioner and got 805 watt hours. And another guy tested it just pulling about 150 watts average with some fans and lights, and he got 825 watt hours of energy, way below the rated claim of 1100 watt hours. So why is the Kodiak so low in its rating versus its rating? One reason, you have to look at how they claim their watt hours. A 90 amp hour, 12.6 volt battery. Well, 12.6 volts is the maximum voltage of the battery. And that's not how you rate them, because the battery doesn't stay at its maximum voltage the entire time it's used. It drops down to, if you run it down to zero, around 9 volts. You actually rate a battery voltage by its nominal voltage, kind of the midway point between the high and the low, to get a more accurate reading. So the Kodiak should have said 90 amp hours at 10.8 volts, which would give it about 1,000 watt hours. Now that's still higher than what we got on the test. I did some research and I found a video of some guy that had actually torn apart one of these Kodiak solar generators, and he was showing some of the parts inside it, and he showed the batteries. They were 18650s, and I actually got the type of batteries and the model number off one of them. Panasonic NCR 18650PF. So I looked them up on the website to find out what their spec sheet said about them. And they are, of course, rated at a nominal voltage of 3.6, just like I said. And a 3S configuration like the Kodiak, that's 10.8 volts, which is how they're supposed to be rated. The interesting thing was these batteries are rated capacity at 2750 milliamp hours. It's interesting, if you're below 50 degrees, they're only rated at 2700 milliamp hours. They also say the typical capacity is around 2900 milliamp hours, probably from the battery getting warm, because the warmer they get, the more energy they'll have. So in this video, the guy also said that the batteries were in a 12 by 7 row. I could see the 12 batteries. I couldn't see the 7, but we'll assume he's right, with a total of 84 batteries. So if we take what is the rating of 2750 amp hours times the nominal 3.6 volts, you come up with 9.9 watt hours per battery. And if you times that by 84, you get 832 watt hours. That's what that battery is actually rated at. Now, if you took the typical rating, it would be about 877 watt hours. But you can't go by that because that's not a guarantee. You have to go by its actual rating. The Yedi 1000 also has a lithium NMC type of battery, claiming 1045 watt hours at 96.8 amp hours and 10.8 volts. In my testing at the plug, I got 900 watt hours. So with an estimated 12% loss through the inverter, the same as the Kodiak, which is typical for this type of inverter, it should have around 1,010 watt hours at the battery. And with a little energy left in the system, it probably does have an actual 1,045 watt hours. Kodiak claims up to 2,000 cycles in their battery. The Yedi only 500. So why is there so much difference when they're the same type of battery? The difference is in the details. Kodiak claims up to 2,000 cycles. That only means anywhere from 1 to 2,000 cycles. That's like saying humans can live to be up to 117 years old. But how many actually do that? If you don't charge the battery over 80% or discharge it below 20%, don't charge or discharge it too fast, don't let the battery get too hot or too cold, it may last 2,000 cycles. But so would the Yeti. Under the same circumstances, both batteries will cycle about the same, 500 cycles, and I think probably even more, maybe up to 800 cycles, would probably be what an average user will get. My solar generator got over 1,900 watt hours of usable energy out of the battery, twice the energy of either the Kodiak or Yeti, which is more than it's rated for. Typically, LFP batteries do that. They seem to have more energy than they're rated for. My 72 amp hour batteries in this system actually got 74 amp hours out that was usable. The LFP batteries in my solar generator can cycle 2 to 3 times more under the same conditions as these other batteries in these other solar systems. I have already cycled my batteries about 500 times over the past year and a half. So even if they cost a little more to buy initially, because they can cycle thousands of times more, in the long run, they're actually cheaper. And I've seen no power loss or anything from my system. It's worked flawlessly. Every night I use it. The inverter is the second most expensive and important part of a lithium solar generator. If it won't start or run the appliance you want to run for however long you want to run it, then it's not very useful. The Kodiak claims it's a 1,500 watt continuous 3,000 watt surge inverter. One YouTuber ran the Kodiak at around 1,300 watts for a little over 4 minutes before it died. Another testing its surge ability ran at around 1,700 watts for about 20 seconds before it died. This was on the 30 amp RV plug. Another YouTuber that owns both a Kodiak and a Yeti 1000 didn't give any details, but he said that the Yeti 1000 was a much stronger and powerful inverter. From the videos I reviewed, the Kodiak isn't a 1500 watt inverter. One guy thought it might be around a 1000 watt inverter. I think it might be a little more than that, but definitely not a 1500 watt inverter as claimed. I ran the Yedi 1000 at 1560 watts for 12 minutes on a test. It ran great. A YouTuber tested its surge capabilities by running it at 2200 watts for 30 seconds before it shut down. The Yedi 1000 is definitely a good 1500 watt inverter. I ran my ultimate solar generator at almost 1900 watts with a microwave for about 15 minutes. It ran great. I use a Kodiak 2000 watt, 3500 watt surge on my solar generator. Although a good 1500 watt inverter will power most appliances, there are still a few things they wouldn't be able to run, like this microwave that I used to test my solar generator. The Kodiak comes with a 100 watt PWM charger. It doesn't give you any information on how many actual watts it's charging at. I found several different specifications on the Kodiak charge controller. One place it had a 20 amp, another said a 30 amp. Another place said it had 24 volts, 26 volts, or 32 volts. I don't know, maybe it has two charge controllers. But since you can only use one at a time, we'll look at only the 30 amp charger. And the voltage doesn't really matter that much as long as it's at least 22 VOC, since these systems can only use a 12 volt solar panel, and most 12 volt solar panels run between 18 and 22 volts open current. A higher voltage spec won't make much difference until you get up to a 20 volt solar panel, which will have around 36 VOC. Kodiak claims 600 watts of charging ability. Since Kodiak doesn't come with an input meter, a couple of YouTubers put one in line between their Kodiak and solar panels. One guy hooked up 6 100 watt panels. He was getting around 440 watts at 34.4 amps. 34.4 amps is over the 30 amp rating of the charge controller. There were no alarms or shutdown of the system. To keep it around 30 amps, you'll need to keep the wattage around 400 watts, which is probably why you only get 5 solar panels in the gold package at the energy store. Much above 400 watts and you're risking damage to your charge controller or worse. The Yedi comes with an 80 watt PWM charger. I have seen it charging between 52 and 66 watts depending on the battery voltage. A PWM charger basically works by dropping the input voltage down close to the battery voltage. A voltage high enough to charge the battery, but won't raise the amperage higher than the charging circuit can handle. This PWM charger on the Yedi is rated at 16 volts and 5 amps. So when you're charging at a low battery around 9 volts, it's dropping over 7.5 volts. But when the battery is almost full, it's only dropping about 3 volts. which is why it will charge at a higher wattage and be more efficient with a fuller battery. The Yedi also has a 30 amp charge controller and claims up to 360 watt charging rate. I used my universal power supply, which I normally use to charge the ultimate solar generator, and hooked it up to the Yedi. It easily could charge at 360 watts and stayed slightly under its 30 amp rating. Since I can bring the universal power supply down close to the battery voltage, there was little wasted voltage, and I saw efficiencies of around 95% from the power supply to the Yedi. But when I included the power supply losses, it was down to about 80%. The Yedi has several connections for power input. You can use them all at once, just don't go over its 360 watt max, which I actually did once while charging it with my universal power supply and its 80 watt charger that comes with the Yedi. It was charging at well over 400 watts. It started beeping at me and then shut down. A nice safety feature to have. The reason I could connect my universal power supply to the Yedi is because it uses Anderson type connectors, just like my ultimate solar generator, not proprietary connectors like the Kodiak uses. The ultimate solar generator blows the other two systems out of the water when it comes to charging. The SBMS, which controls the charging, doesn't use PWM or MPPT. Charging just constant current. At around 99.6% efficiency, it's more efficient than either PWM or MPPT. Over 700 watts is what I've tested it at, the most my universal power supply can produce. It is capable of charging at 1800 watts with these batteries in my solar generator. 3500 watts is possible with the SBMS with larger batteries. For long cycle life, I only charge the batteries at around 1/3 C, about 600 to 650 watts. The Kodiak is the lightest of the three systems, and since it has the smallest battery and the least powerful inverter, that makes a lot of sense since those two items make up most of its weight. You would expect it to be lightest. The Yedi is in the middle with its bigger battery and more powerful inverter than the Kodiak. But compared to the ultimate solar generator, it has a much smaller battery and inverter. The ultimate solar generator is the heaviest, but still hand carryable. The Kodiak has a small and simple two-color display with a constant voltage, amp, and wattage readout, and a revolving display of BM, WP, AH, WH, and AP. What's really missing is information about the input charging. The Yedi has a two-color display with 3 real-time measurements and a graphical picture of a battery and its state of charge. Input in watts, output in volts, watts, watt hours, percentage charge, hours to full or empty, depending on if the battery is charging or discharging. The SBMS on the ultimate solar generator has a large multicolor display with about every piece of information you could want or need. Details about each cell in the battery, both text and graphical. With so many screens of information, you might think it would be hard to use or understand, but it's not. It's amazing. Does the Kodiak live up to its specifications? No. That doesn't mean it isn't useful. It can power light to medium loads for a fair amount of time. Charging at over 400 watts is respectable. The problem is when you can't charge it up, like at night, cloudy, rainy, or snowy days. With its small battery, it will run out of energy quickly. It has 6 120 volt plugs. Why? 2 plugs are enough for most people. If you need more, just go buy a $5 power strip. It has an RV 30 amp plug. Why? Most people won't use it. If you do, just buy a $7 adapter. 2 cigarette lighter type adapters. Again, why? I think they wanted the Kodiak to look like it can do more than it can. For its expensive cost, the Kodiak is something I wouldn't be interested in, with much better choices available. Does the Yedi live up to its specifications? Yes. It's designed well, except for a few problems I ran into. For the price, this 1 kilowatt hour, 1500 watt solar generator is a good choice for those that don't want to build their own or can't afford a more expensive system. The output information isn't very accurate, and I believe the shunt is located after the inverter. It's hard to tell. The PWM AC charger that comes with the system is too small. Their optional MPPT charger helps, but it's still too small. I hear they may come out with a 300 watt or so charger soon. That would help. What's nice is that they have Anderson plugs available, which I use to connect my universal power supply to charge it at over 300 watts. That's a nice feature, so you don't have to buy a proprietary connector like the Kodiak uses. Does my ultimate solar generator live up to its specification? Yes, of course. I designed it to be the best portable, hand-carryable solar generator, and from everything I have seen, it still is. The LFP batteries cost, and their weight is a little more than the MNC batteries, but when you consider they will cycle 2 or 3 times more under the same conditions, they are less expensive in the long run. I can set the voltages in the SBMS to only allow the batteries to charge and discharge between 20 to 80% to get thousands more cycles. You can't do that with the Kodiak or Yedi. So solar generators don't work by themselves. They need things like lights, extension cords, power strips, adapters, connectors, etc. I have built-in storage, so you don't have to carry a separate container. Okay, let's talk about cost. Kodiak on their website advertises it for $1,875. I've seen people and different websites offering a discount of about 20%. So you can probably pick it up for around $1,500. But that's just the price of the Kodiak. Let's add 5 100 watt solar panels, 3 lights, and all the connecting equipment. It's over $3,200 in their gold kit. This would be just a basic system. The Yedi 1000 on the website, it's $1,300 retail. Costco sells it for $1,000. But it just so happened I saw it being discounted at Costco, the sell price of $850, which is just about half of what the Kodiak cost. And it's a better system, in my opinion. If you add 100-watt solar panels, lights, and all the connections, price of around $2,500. Much less than the Kodiak, but still not cheap. Okay, the ultimate solar generator. My cost was around $1,450. And since my system is a 24 volt system, I can use 20 volt solar panels. 24 volt panels would also work, since the SVS can handle up to 47 VOC. 300 watt, 20 volt solar panels can cost less than $200 each. Two would have more power than 5 100 watt panels. About $25 for my 4 3-watt lights, homemade legs, common connecting equipment. Less than $2,000 for the entire system. As you can see, not only is my solar generator superior in almost every way to store-bought systems, it costs less too. Some may say, what about the time I spent building it? Isn't my time worth something? It did take a while to build. I look at it as entertainment and a learning experience. I enjoyed building this as much as going places and doing things on vacation. I'm retired. This was a fun and rewarding project for me, and I learned a lot. I would have paid a lot of money to have as much enjoyment and learning as I did with this project. Why did I buy the Yedi 1000 at Costco when I already have a much better system? $850. I could make a more powerful solar generator for around $1,000. The Yedi 1000 regular price, but for $850, I couldn't. One thing you should consider if you want to buy or make a solar generator with NMC batteries. Their voltage rating is somewhat different than a lead acid battery that most 12 applications are designed to run on. LiFePO 4 batteries are closer in voltage. I haven't had any problems with them, where NMC batteries are totally discharged at 9 volts and fully charged at 12.6 volts. This can cause problems, such as my Dometic freezer wouldn't even run when I plugged it into the Yedi 1000. I did adjust the automatic battery saving feature to 11.1 volts, but it still shut off half full. As you have seen, the ultimate generator is still better than any hand carryable solar generator out there. If you don't want to build your own, the Yedi 1000 would be a good choice for the money. I hope this helped give you a better understanding in choosing a solar generator.